Hey C-Block. Alright, so this is a video about UBFM.1, 2, and 3, the mastery level problems. This is also from the quiz 41119. Alright, so the problem reads, a stationary 5 kilogram box is pushed against by a rightward force of 60 newtons while on a rough concrete surface where the coefficient of static friction, which is abbreviated μs, equals 0.6, and the coefficient of kinetic friction, which is abbreviated μk, equals 0.4, so that it begins to slide. Alright, so the information then I've summarized in this given box. So we're given that the mass is 5 kg, the force of the push is 60 newtons, the coefficient of static friction, meaning the amount of friction, or what you would multiply a force by if you were to figure out what the friction was when it's not moving. So this is what you would multiply the normal force by. And the coefficient of kinetic friction is 0.4, and we're given that it is sliding. That is actually crucial information because it helps us pick which one of these coefficients of friction to use. So because kinetic means moving, this is the one we want. So part of this whole problem was to see if you could choose the correct coefficient of friction to use. So the one that we want, because it's sliding, is we want 0.4. Alright, so the force of gravity. So F equals ma. Right, and the mass is 5. And the acceleration due to gravity, we're going to say, is 10 meters per second, or 10 meters per second squared. If you use 9.8, that's a little closer, but we're good with 10. And 5 times 10 equals 50. The box is not falling or rising, so the normal force is going to be the same thing. So that's also going to be 50. Let's use our units. 50 newtons in each case. And the force of friction is going to be the normal force, or 50, times the coefficient of kinetic friction, and 50 times 0.4 equals 20 newtons. We're being asked to find the acceleration. Notice that I left a little blank space here. There is a hidden question in this, and that's in order to find acceleration. You're given a hint on the previous page about this, but you're not given a hint on this page. But you can use that hint from the previous page about this. You also need to find F net. So up and down, it's 50 either way, so the net force is 0 there. And so now we need to find the difference between the push, which is 60, right? We've got that in our given over here, and 20. We've got friction's going to be resisting the push, isn't it? So that's going to be 60 minus 20, and that equals 40 newtons, and it's going to be going still to the right. Now we're set to find out what our acceleration is going to be. Our acceleration is going to be, let's draw our triangle again, F equals ma. So if we cover up a, we find that a equals F divided by m. And so the force is 40. The mass is 5. That's in our given. 40 divided by 5 equals 8. We're being asked to find acceleration, so that's going to be 8 meters per second squared. That's how to do the mastery problems for UBFM 1 through 3 from our quiz 41119. Alright, I just noticed that I did not draw you guys a free body diagram. So here is the box. And we've got 50 newtons up. And that's going to be our normal force. 50 newtons down, force of gravity. And we've got a force of a push. I'm going to make that a little longer so that it looks longer than 50 newtons. So that's going to be 60 newtons. Sorry, it's hard to write from this angle. 60 newtons, and that is F push. And then our force of friction, F equals 20 newtons. And that's how you would do the diagram. Notice that I at least tried to get this arrow pointing to the right to be bigger than our normal force and our force of gravity, and then I made our force of friction quite a bit smaller than all of those, so maybe a little less than half the size. At least that's what I was trying to do. And if you were working with a graph, you would just use your boxes. A sensible way of arranging this would be to have each box equal 10 newtons, and you could indicate that or just write carefully on your graph.